Hello guys and welcome to this video on matrix multiplication. My name's Darren, Maths Guru, and it's always good to see you. Now this is a continuation, and I've been doing videos on matrices where we've done all the important and exciting stuff, including scalar multiplication. What's this video about? Well, it's taking it that one step further, and this course builds and builds and builds. So if you haven't watched the previous videos, please do so. And while you're at it, can you do me a favor and subscribe to YouTube? Just lets me know that you're watching. Never going to be rich, never going to be famous. And if you need to, there are notes. If you want these notes with me written all over them, and you want to write even more, then download them. Head to mathsguru.com. There are notes, there are time codes, there are exam questions. There's all these videos sorted by textbook. I've tried to be as helpful as I can and spread the word. That would be greatly, greatly appreciated. All right, what are we going to do today? Well, we're going to understand how to perform multiplication of matrices, know the rules, and to know that in general, and this is really, really important, matrix multiplication is not commutative. It's not. Basically what they're saying is that when sometimes, you know, like in maths 2 times 3 is the same as 3 times 2, that's commutative. But basically for matrices, that's not always or generally the case. So we need to remember that that may well try and come and trick us. Now, what are we dealing? As I said a moment ago, we dealt with scalar multiplication. That was where we took one matrix, and here we defined matrix A. And then by doing 2A, it basically told the calculator to take every one of the elements and multiply it by 2, which is exactly what came up there. So if we took each of these individual elements and checked its partner, we would see that they would double in size. That's scalar multiplication. Okay, now we're going to play a game of odd one out and in fact spot the mistake. Now I recorded this just a moment ago and I've gone back and deleted it for a very specific reason, and I was going to trash this whole video, and then I thought, well no, hold on a moment, there's some learning here. So we're going to play 2 odd one outs. Right, so what we've noticed here is my calculator has basically turned around and I've got 4 matrix multiplications. I'm going to come back with that idea in just a moment. There is a very definite odd one out here. And what we've noticed is for this first one here, when I've done 1, 2, 3, 4 multiplied by 1, 2, it has given me a matrix as an answer. Now when I'm skipping that second one, and you'll see why in a moment, all right? This one here and this one here. Now I've got 2 matrices multiplied together, but what do you notice? Well, this is basically your calculator going, you're a muppet, you can't do it. I'm not calling you a muppet, although we're friends now. I'm sure we're okay with that. Yeah, when your calculator says error, dimension error, it can't be done. Now, how did I know that something wasn't quite right? Well, a moment ago when I recorded this, I said, oh, actually, yes, this is okay, and it's given me an answer of 2. But actually, do you notice the problem? And if you've watched the previous video, you'll know exactly what is happening here. And that is, there's no dot between these two here, all right? Now, because there is no time sign here, what's actually happening is that there, because it's in square brackets, is giving me an element, OMG. I had no idea the CAS could do that, but what it's actually doing is, it's giving me row 1, column 2's element, which happens to be a 2 there. So here's a huge learning for me, to be honest with you. The Casio ClassPad, I don't think it does that, but the TI Inspire does. If you don't put a time sign in there, you're going to get some really freaky answers. So sadly, that sort of failed, yeah, because I was partway through this bit going, oh, life is good. But what I'm going to do now is come back and say the order of the matrices is really, really important. I'm actually going to get rid of this one here for a moment and say, let's ignore that because it's not really a valid example. If I look at here as the 1, 2, 3, 4, and what was it, 1, 2, let's look at the order of these. So that was a 2 by 2, put it in brackets for no reason. I don't know why I'm putting it back, and a 2 by 1. Now, something about that said it was okay. This one here though, what did we have? We had it the other way around, 1, 2, 1, 2, 3, 4. Let's see what happened. That was a 2 by 1 and a 2 by 2, and that couldn't be done. And likewise, if we had 3, 2, 1, 4, 5, 6, and 1, 3, let's look at the order of those. What did we have? How many rows are there? There's 2 by 3 and 2 by 1. So that was okay, and these couldn't. What on earth is allowing this to happen? Well, ladies and gentlemen, the trick to know whether you can multiply matrices together is are the two middle numbers the same? Huh? What do I mean? Look at that. That 2 and that 2 there are the same. And when they are the same, we can multiply these things together. Because that was a 1 and a 2, no good. That was a 3 and a 2, no good. So going back to my previous video, remember I told you to write down the order. It's going to make life so much easier because we can only add and subtract when they're the same order. The same with multiplication. It's going to absolutely make your life so much easier. And there we go. The order of the matrices tell us if they can be multiplied. Now, the specific language that we need to use, you can't just say the middle two numbers are the same. I learned that previously in a SAC, sadly, is that you have to say the number of columns of the first matrix. All right, so the number of columns of the first matrix has to be equal to the number of rows of the second matrix. And the order of those matrices, really important. Okay, so 3 by 2 and 2 by 1. Now, as a bit of a side consequence, let's go back and have a look. What did we notice about the size of that matrix there? It was a 2 by 1. What do you notice about the outer numbers? 2 and 1. Oh my goodness! If the middle numbers are the same, that means you can do it, and the outer numbers tell you the size of your matrix answer. Wow! Again, this order stuff, I'm telling you, really important, yes? So, as I say here, because that's a 3 by 1, that's the size of my answer. My answer would be a 3 by 1. And if I need to, I could actually write that, draw it out, and start to fill in the values. Okay, so we haven't done the multiplication yet, but we are getting there, I promise. Again, I've made a big deal in previous videos about elements. Remember, the elements of a matrix, really important. This element here would be C11, C12, C13. Yes, row first, then column. This would be C21, C22, and C23. Now, actually, these addresses help us work out how to get our answer matrix. Now, what I mean is, if I had a 3 by 1 matrix, yes, then I would know that this one here, let's call it A for answer, would be A, how many rows? 1, 1. This one here would be A2, 1, and this one here would be A3, 1. So to get the answer to this number here, I would do the first row times the first column. Again, I'm coming to that in a moment. This one here, A2, 1, I would do the second row times the first column, A3, 1, third row, first column. And all you're going to do when you multiply matrices is multiply numbers and add them. Right, so let's have a look. I'm going to show you how to do it. I've got a number of examples. So we're going to try and find A, B, which is the same as A times B. So 7, 4, 5, 6, multiplied by 20 and 30. Whew. All right, so when we multiply, let's do the order first. That's a 2 by 2, and that's a 2 by 1. Are the middle two numbers the same? They are. And what is my output going to be? It's going to be a 2 by 1. Okie dokie, so this is going to be a 2 by 1. Now, remember this here is going to be AB, 1, 1. And this is going to be AB, 2, 1. So what it tells you is, to get the value here, I'm going to do the first row times the first column. So if I now use a highlighter, where is my first row? It is here. Where is my first column? It is here. So I'm now going to have to somehow do 7 and the 4 and times it by the 20 and the 30. How do we do that? Well, you go across the row and down the column. And what do I mean by that? I'm going to do the 7 times the 20. So I'm going 7 times the 20 across the row and down the column. And then I add the 4 times the 30. Now you're going to say why, and I'm just going to say, guys, you just accept it. You go row by column, first row times first number, second row times second number, as it were, as you go. So notice I'm going across and down, cross and down. All right, so let's work that out. 7 times 20 is 140, 4 times 30 is 120. Add those together, gives me 260. How do I get the next one? I now do the second row times the first column. This is my second row now, and I've already got my first column. In fact, there's only one column, so that makes life a bit easier. So let's see what that's going to be. Well, I'm going to move along that bottom row, 5 and then 6. So I've got 5 and then 6, and I've got the 20 and the 30. So 5 times 20, 6 times 30, and add them together. Orange on orange wasn't the best choice of colors, was it? 100 plus 6 times 30, 180, which gives me 280, 280, and ladies and gentlemen, ka-ching, there we are, our matrix multiplication. All right, I've got a number of other examples, don't worry, that is basically how to do it. All right, let's do another one, right? So we've got 3 more examples here. All right, so the first one, let's do this one here, which is A times B. So let's just write out A first, 5, 2, 4, 6, 1, 3, times B, which is 8 and 9. Right, so first things first, check the order. Can we do the order? So this is how many rows? 3 by 2, and this is 2 by 1. Are they the same? Yes. So what's my output going to be? It's going to be a 3 by 1. All right, so we're going to get a 3 by 1. All right, so what do we do now? Well, we know that this one here is going to be AB11, AB21, AB31. So row 1, column 1. Row 1 and column 1. Well, there's only ever going to be one column, so that's going to make life a bit easier. So row 1, column 1. So let's see what we're going to do. 5 times the 8. So first number by first number plus the second number by the second number. 2 times 9. Well, 5 times 8 is 40. 2 times 9 is 18. So that's going to give me 58. So my first number there is 58. Then my next row, or my next element is 2, 1. So row 2, column 1. Row 2, column 1. So that's going to give me 4 times 8 plus 6 times 9. Most of this is about your times tables. 4 times 8, 16 is 32. Plus 54 gives me 86. And then 3, 1, third row, first column. So third row, first column, and that's going to give me, well, that was silly, 1 times 8 plus 3 times 9. Could have chosen a better color there, which is 8 plus 9, 18, 27, which gives me 35. And there we go, ladies and gentlemen, 35. That's just a process. If you know the size of your final matrix, and you can do the rows times the columns, you're done. What's about the next one? BA. So B times A. Now you're going to try and say, well, it's the same. Careful, let's have a look. B times A is 8 and 9 times A, which is 5, 2, 4, 6, and 1, 3. All right, so let's do the order. That's 2 by 1, and that's 3 by 2. Are they the same? No, they're not. So in fact, this is not possible. And the way we say that is we say it is not defined, all right, which is pretty much what your calculator was trying to say, but our language is it's not defined. It is not possible, all right? So notice it was interesting how we could do A times B, but we can't do B times A, which goes back to that stuff we were talking about at the very beginning of the video that basically went, well, don't think that they are the same. And what about the next one? C times D. All right, so we'll do C, D, which is going to give me, C is 2, 4, 7, times D, which is 8, 6, and 5. All right, so what is this? How many rows? 1 by 3, 3 by 1. Are the middle numbers the same? They are. Ka-ching, thank you very much. Which means we're going to end up with, actually, in this situation, just a 1 by 1 matrix. Why? Well, because this is just going to have C, D, 1, 1. It tells us just to multiply that one row by the one column. And how are we going to do that? Well, there's my row, there's my column. And so how do we do this now? Well, each number in that row pairs up with a number in that column, multiply the pairs and add them together. So we're going to end up with 2 times 8 plus 4 times 6 plus 7 times 5. So 2 8s are 16, 6 12, 24, 7 5s are 35. Add those together gives me 40, that gives me 75, and ka-ching. If I got my maths right, it is in fact 75. Now, obviously, we can use the CAS to do these questions. Sort of makes sense. It's a CAS course. And again, just make sure that when you do them, put them in as defined and don't do that silly thing here where you miss out the time sign between, because it sort of throws a spanner in the works. And pretty much I'm done. Thank you very much for watching, guys. There is a couple more minutes left. If you could watch it, I would be deeply, deeply grateful. If not, and you have had enough of my rather dull voice, then I look forward to seeing you in another video. Hopefully, spread the word, subscribe, and hopefully I'll see you on maffsguru.com. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is maffsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.